I'd like to show you how to use a powerful tool in Excel that has to do with regression and correlation of data. And I hope that you'll find this to be a valuable tool, and then you give that a try when you have an opportunity with your own work. So here we go about regression and correlation tool in Excel. And so here's our objective of this video is to say, I've got to move my Zoom menu here. Just excuse me a second. Okay, there we go. What is linear regression and correlation? So we're going to restrict a discussion today to simply fitting a straight line to data. I'm going to introduce an imaginary demo problem in which I'll show you that I've got some data that I've created. Then we'll look at some basic statistics about that data. And then once we've sort of looked at the basic statistics, visualizing the data in Excel, and then doing a linear regression on the data to make some predictions about how Y is associated with X. We'll do that both graphically, and then I'm going to show you another powerful built-in formulas in Excel where you can get this data right into your spreadsheet. So here we go. All right, well, what is linear regression and correlation in the first place? Well, gosh, I hope that this looks familiar to you. Let's say you've taken some data, Y and X. Okay, so those are data pairs, and you've plotted Y against X, and you put it down on the graph. You say, wow, those little data points I see that a straight line could sort of fit that data, and we'll describe that line as Y equals mx plus b. And we're going to try to figure out what's the formula, what is m and what is b. So quick recap, just to be sure we're all on the same page. I learned this in 7th grade. Now, you may have learned it a little earlier than 7th grade, but this is when I was introduced to this idea of Y equals mx plus b. That's basically the equation of a straight line with slope m and y-intercept b. And so what we want to do in this particular situation where we've taken some x, y data pairs is we're going to try to find out what is the best numerical value for m, the slope, and b, the intercept, that best describes a straight line, a linear line that goes through that data. So you can imagine sort of eyeballing a straight line that goes through your data, but we're going to be able to determine mathematically what is the best line to use. All right, so let's get right into my imaginary research project. So I don't really have a pet rooster, but let's imagine that I have a pet rooster, and I go out and feed the rooster and talk to it, and things like that, pretend like it talks to me. But I've observed in the mornings that the rooster crows every day around sunrise. And I find that is kind of interesting. And so what I want to do is explore the relationship between my rooster's crowing in the morning and the sunrise time. And so I went out and I spent 6 months writing down pencil and paper, a clipboard. I've recorded the time on the clock when the sun rises. And then I've also recorded on in my clipboard when my rooster crows. And I've done that for 6 months, every day. Okay, great. So I've got this clipboard full of data. Now what? And so the question is, can Excel help me with this analysis? And so there's my icon to remind me to go live. And let's go to Excel. Okay, I've done a little pre-work, so we're not going to start from a total blank slate. I'm going to open a file called regression demo. Okay. And here's my data. I have dutifully entered my data from my pencil and paper clipboard into Excel. And so let's scroll through and see what we've got. So for example, let's look at data point, I don't know. And so I'm going to scroll down and look at data point 49. So data point 49, so the sunrise time, it says 6.53. So that represents around 6:30 in the morning. Okay, 6:30 in the morning. So 6.5 would be like 6:30 clock time. And I see that on that day, my rooster crowed at 6.75, that 6 3/4. That would be kind of like 6:45. So sun came up at 6:30 and the rooster crowed at 6:45. So, okay, let's keep scrolling down. And I kept continuing to take data. And I took data for 180 days, about 6 months. All right, so there is my data. All right. Now, what are we going to do with that data? If you're anything like me, I've got 180 data points, but I'd say, so what? It's just a bunch of numbers. All right. Well, let's do some analysis first. First, let's just do some basic statistical analysis on how many data points do I have on sunrise time. So the count of data, I'm going to type in equals count. That's an Excel formula, count, and I'm going to go to my data log, okay, and I'm going to click column A. And so the formula says, I want you to, Excel, what I want you to do is I want you to go to column A and count the number of numerical entries that are there, 180. All right. Now let's look ahead, and what I want to do the same thing with the rooster crow time. So let's look at this formula, count, data log AA. If I drag this cell one to the right, let's see what happens to the formula. It's count of data log BB. Well, there's BB. I made a mistake, didn't I? So just excuse me. I counted the number of data points. So pardon me. On my sunrise time, I've got to change. I need to change my formula here, don't I? So I'm going to wipe out. Pardon me. Gosh, I'm going to delete that. I've got to select the correct number of data. Sunrise time. That's column B. There it is, 180. Let's drag. Okay, so here's my formula, data log BB. Let's drag my formula to the right and look at the new. Oh, when I drag my formula to the right, it moved the column, one column to the right, okay? Well, that would be the count of my rooster crow time. And so I'm going to drag this formula down to here, okay? Look at that, that's kind of a time saver. Let's do the average. The average sunrise time equal average. Okay, that's a built-in formula of what? Sunrise time. Let's go to my data log. And I'm going to click column B and take the average of all those numbers. And the average is 6.98. And so the average sunrise time over 6 months is about 7 o'clock. Okay. How about rooster crow time? So notice the formula. If I drag the formula to the right, it's going to keep the function and slip my column data log average of data log CC. Okay. And so now I've got the average rooster crow time is 6.85. So it's a little bit before on average, a little bit before the sun comes up. Interesting. Okay. How about the minimum sunrise time? Equals minimum of sunrise time. And I'll hit enter. Okay. The minimum is, looks like about 5.49. That's about 5:30, isn't it? Okay. And I'm going to box that out. Let's do the same thing about my rooster crow time. The minimum rooster crow time is, well, a little bit before. Okay. How about the maximum sunrise time? The latest sunrise time equals max of sunrise time. Data log, column B. Maximum is, well, 8.4. So that's a little bit before 8:30. That's the maximum sunrise time that I logged. Okay, going to do same thing with my rooster crowing. Look at that. It's about the same maximum rooster crow time. And now let's just do some math. Max minus min. It's just a formula, equals the max value minus the minimum value. And so looks like about 3 hours difference in that data. Okay, so we haven't learned a whole lot. So The next thing would be, but at least we've checked our data. We've got 180 data points. We have an average time of around 7 o'clock rooster crow and sunrise time. Okay, let's do some graphics. Let's insert. I'm going to click insert. Let's see, it's scatter plot. Okay, so let's drop down this menu, the scatter plot menu, and let's select dots. Okay, and look at that. So Excel creates sort of a template or just a blank region for me to create my graph. Okay, so what I'm going to do in here, I'm going to click in my blank slate graph. I'm going to right click and I'm going to select the data that I need to plot. And so I'm going to so I like to do things one thing at a time. So I'm just going to do it manually. I'm going to add a series name. Let's see, a series name. Let's click. And so what should Y be? What should X be and what should Y be? The series name is going to be the Y data. I think it should be rooster crow time because it seems like to me that sunrise time is kind of like an independent variable to me. That's something that doesn't change. If the rooster runs away, he's gone. So let's select the Y should be the rooster crow time. So I'm going to click this cell and that's going to be the series name, rooster crow time for Y. Okay. Now we're asked to say, what's the X values? Let's select the X values. Okay, so I wipe that out. And so I'm going to come up here and select sunrise time. So this set of data, there it is. There's my X sunrise time. Okay, Y values, I'm going to wipe that out. And my rooster crow time is my Y set of data. And let's click OK. All right, good. So we're doing pretty good. And then OK. So we've got rooster crow time, one series, and we've plotted it. Great. All right. Let me take you through. We've got 12 minutes. We're doing fair. Okay. I'm going to wipe out this title. Okay. And this is what's called the legend. And I'm going to right click on the legend and I'm going to move the legend up to the top of my graph to get the most bang for my buck. All right, so now let's look and see what we've got. Well, gosh, the X and the Y both start at zero time. And look, it makes sense. So here's where our data is. We can, if we click on our axes, we can do a lot better job of spreading out our data on our graph. So I'm going to right click. I'm going to left click the X axis. Then I'm going to right click and format my axis. And I'm going to make the starting point for the axis. Let's make it the hour 5. Okay. And then the maximum, let's make it 9. So 5 a.m. to 9 a.m. is going to be our x-axis range. See how that spreads it out? Let's do the same thing for y. I'm going to left click on the y, then right click, format my axis, and let's go fixed, 5 o'clock in the morning, and fixed on the y max as 9 in the morning. Okay, see, look how much better that looks, right? I think that looks a little better. We've spread our data out, and now we can see our data. Ooh, and this data looks, it looks kind of linear, doesn't it? Okay, I think a straight line could fit through there. And so in the old, let's say elementary school or junior high school, you would have had pencil and paper and you would have drawn a line through and then maybe graphically sort of estimated what's the slope M and what's the intercept B and things like that. It is so cool for Excel is what I'm going to do is right click on any of the data. So I'm just going to get my cursor just in general in line with my data, rooster crow time, that's Y. Okay. Well, before I do this, I think it makes sense to click on my graph and then, so I'm struggling to move my zoom menu. Okay. And let's see, let's the layout, the format, the design, let's layout. chart tools layout. And I should label my axis titles. So primary, that's the horizontal axis, that's X axis. Let's title the X axis, and I'm going to come in here in my formula area and just type sunrise time, hours, and hit, okay, that's better. Okay, then let's do the same thing, axis titles, vertical axis title. Let's say rotated title, so it'll fit sort of vertically. Okay. And then let's type in rooster crow time in hours. Okay. I think that serves us a little better. So now, no matter what role you're in, whether you're engineering, you're a business major, scientist, mathematician, now you know what is defined as X, what is Y. So, okay, I think that's better. Now back to, how about let's come up with a good value for the slope M and the intercept B. This is so easy, and this is the trick. We're 16 minutes into the video. I'm going to right click on any of the data. Okay, and let's see. Let's add a trend line. Add a trend line. Okay. Got to move my zoom menu again. Okay. We have to pick what type we want, and let's keep it simple. A straight line. We're selecting linear. That's like the default. Okay. And what else do we need to select? Let us display the equation on our chart. So we're going to click that. That's going to give us the formula, y equals mx plus b, and also a statistic about sort of how much the dots get, how close the dots are to this equation, this curve fit, this regression equation on. So let's click display R squared value on our chart. So I've clicked both of these and close. Wow. And so I've got this little text box, and I'm going to move it. Okay. And in fact, let me blow up the size of this little text box. I'm going to come up here to font and make it bigger and bigger and bigger to talk about it here. Okay, so that's better. Okay, now I'm going to click away from my chart. And wow, look at this. We have visualized our data with a scatter plot. We right-clicked on any of the data, added a trend line. Okay. And in fact, let me click on the trend line now. I've clicked on the trend line. I had to look closely. Let's format the trend line and let's make it fatter. Okay. Line style, instead of this little wimpy 0.75 width, let's make it 3 to make it bold. Okay. Now we've got something. Okay. Now we can talk about it. So this bold line is the linear regression curve fit. See how Excel has titled it for you, linear rooster crow time. So it is an expression of y equals m 0.997 x plus b, well, negative minus 0.1079. Okay. And it gives an R squared value of 0.9111. Okay. This is great. Okay, now R squared, it's not exactly a goodness of fit. Okay, I've got a slide that's coming up back in PowerPoint that describes what R squared is. But one thing I will tell you is that as R approaches 1.0, that means that all the data points are pretty closely spaced around that linear line. For R values that are smaller, let's say R squared equals 0.7, that means that the data points are going to be more widely spread around that line. So a lot of spread in the data for R values low. So you could stop here if you wanted, but I want to show you another valuable thing that's going on in Excel that enables you. Well, let's say you wanted to continue your little research project on our rooster. Okay. If you stopped here, you'd have to write down with pencil and paper, M is 0.997 and B is 0.1079. Now you'd only have 3 significant figures for M. Okay. You'd have to pull some other tricks to get more significant figures. But what I want to show you is how to get this number M and this number B, the intercept, and R squared straight into Excel. And that is very powerful. And it took me a while to discover that. So I'm going to go, I've prepared a cheat sheet for myself. What is the slope? How do we get 0.997 in Excel without fat fingering it in? Let's say our data changes. Okay. So the way we do that is a built-in formula equals slope, parentheses. Now it prompts me, what are the known y's? I've got to go select my range of y's. I go to data log. Let's see, y. Y is rooster crow time. So I'm going to select this range. There it is. Okay. And then I'm going to hit comma. I'm going to click up here in my formula, comma. And now it says, what are the known X's? The known X's. Well, that's sunrise time. So I'm going to come up here. I'm going to scroll back up. I'm going to select my X values. Close parentheses, and boom, there it is. The slope is 0.997009, just like that. There's the formula, slope. The range for the Y, the range for the X. Same idea for the intercept. Other formula equals intercept. Okay, go pick my Y's. I've got to pick my Y values. I can select from bottom to top, just like that, comma. Select my X values. I can go top to bottom, close parentheses, and enter. And all of a sudden, let's look at the formula, equals intercept, Y data, X data, and there it is, 0.10786 and change. Value for R squared, okay, equals, and the formula is RSQ for R squared, RSQ. Known Y's. We'll go bottom to top, comma, X values. Close parentheses, and R squared is 0.911. So if we changed our data, so you could use this again as one of those user tools, right? So it doesn't have to be associated with the rooster crowing and the sunrise. You've got a little bit of a template and you can change your data. And now you may have to change your the scale of your graph a little bit, right? If your data isn't between 5 and 9, of course it won't be, but you get the idea that when the numbers change, all of these statistics change as well. So let's recap before we go back to PowerPoint in 23 minutes. Let's recap what we did. I took data for 6 months, so I have 180 data points. Okay, that's the first step. Then I went in, I sort of just did some checking of my data to be sure it looked pretty good. And then I plotted my data using Excel graphing tool, scatter plot. I could pretty it up, but I just in the use of time, we'll save that for a little later time. But anyway, those are my points and a little light blue dots. They could be prettier, but then we right-clicked on the data and we added a trend line, and we filled out sort of a user form that said, not only do I want you to show the trend line on the graph, I also want the equation and the R squared values on the graph. So, okay, that's kind of cool. That's very nice. How can I save myself from having to write numbers down on pencil and paper and then re-enter them if I have to do more subsequent analysis work? So I showed you then how to get these numerical values into Excel cells with formulas using equals slope, Y values and X values, intercept, Y values and X values, and for R squared value, R squared, RSQ, Y values and X values. And let's see, I made a bunch of good changes. I'd better hit File Save before I minimize and go back to PowerPoint. Okay, 25 minutes, and now you can you're seeing how to do this linear regression in Excel. What is R squared? R squared is could also in a lot of textbooks called little r squared, but it's called the correlation coefficient. That's what R squared is, not just R, but R squared, correlation coefficient. Okay. This is really important. The second check, that what I've checked off here is the correlation coefficient R squared is a measure of how well the variation in Y, the change in Y, as it gets higher and lower, how the variation Y is explained by the variation in X. So that is that's the word description of what correlation coefficient is. It's a measure of how well the variation in Y is correlated or explained by the variation in X. So R squared does not suggest, so what is not true is how well Y is predicted by X. So that's the scientific name for Y being predicted by X is called causality. In other words, does X cause Y to happen? And my next slide, I hope, is a little bit of a humorous but important thing to think about as you're dealing with data and you're correlating data and you're coming up with regression equations like a linear equation, Y equals mx plus b, to describe the relationship between Y and X. Okay, and so really want to remind you, making statistical conclusions with data. So here's a picture of my pet rooster looking at the sun or deciding what to do. And so here's what check. You can make this statement with the data we took for 6 months. There is a good correlation between the sunrise time and when the rooster crows. That is a true statement, well backed up by facts. Okay. I put a big X next to this one, and you might think, here's the claim. The rooster causes the sun to rise. Do you see that if you got hooked up with a very persuasive person that took this data, and you really trusted that person, you really think the world of that person, do you see that that person might try, perhaps if that person had an agenda, that person might try to convince you that the rooster causes the sun to rise and take you down that road. And so if you think about this a little bit, that there can be some dangers associated with that. Imagine that. So your common sense tells you, of course, that the rooster cannot cause the sun to rise, right? But think about thousands of years ago. And maybe thousands of years ago, someone might have tried to use Excel to convince you that the rooster causes the sun to rise, and we didn't have a fuller understanding of our universe and the way the planets work and the way planets rotate around the sun, et cetera, et cetera. Can you see that somebody might try to convince you that the rooster causes the sun to rise? And now your common sense says that can't be true. Now let's look at the next one where I put a question mark on it. The sun causes the rooster to crow. Now you might say, oh yes, now that would be true. Yes, the sun causes the rooster to crow. Suggestion is you might need to head scratch a little bit about that and think that maybe there's more to it than the sun causing the rooster to crow. And so this is a good, I'm just going to leave it there, and we're not going to get to the bottom of it, and we're not going to do rooster analysis and then go through the science of all this. But you do see that there is a potential pitfall in making general sweeping conclusions from well-recorded data. So anyway, that a little bit for your enjoyment, but do think about this, that on these 3 statements on here, the top statement, there's a good correlation between sunrise time and rooster crow time. That's a true statement that is backed up by facts. The other 2, not so much. And certainly the middle one, our common sense tells us that that's crazy. Okay, let's say you want to learn a little bit more about what's behind R squared. I didn't do any of the mathematics. We're moving on to 30 minutes now in the video. And so if you're interested more in how do you get R squared, how did Excel get a numerical value for R squared that's in our case, it was close to 1.0. In other words, the data was pretty tightly uh, distributed around that good best fit linear line. Go to Jay's Toolbox website, click, drop down the toolbox menu, go to PowerPoint documents. This is one of my PowerPoint topics. And if you click on my PowerPoint regression and correlation, then you can possess some more notes that gives you some background on how do you mathematically get R squared. And so those people, engineers who are taking statistics as a course, you can derive the relationship for how to find what R squared numerically is. Okay, let's look at the takeaways. I've tried to give you a quick review and a quick lesson in how to perform linear regression and correlation. Tried to show you it is a powerful and widely used analysis tool throughout engineering, business, and all of the roles. Okay, linear regression is easy to implement in Excel, both in graphics, which would be a must, and then beyond graphics, the four Excel built-in formulas, slope, intercept, and RSQ for R squared, that enables you to get those numerical values into an Excel cell. And then finally, be careful with conclusions that you make with your data. There are pitfalls to making to jumping at conclusions with data. And so your job is to make clear what's your source data, what are the analysis results, and then be very honest in your communication with what you think your conclusions are with your data and your regression and correlation analysis. I hope that gets you interested in trying regression and correlation with your own data. Think about projects that you're working on, either in school or on the job, or something that you've simply self-assigned yourself to do. It is so easy to do linear regression and correlation in Excel, and I hope that you'll consider working on that in Excel in your upcoming work.